Previously, we discussed the importance of root locus and also the motivation behind it. Now we want to actually start looking at root locus. The way we are going to teach root locus is kind of to show you the end first. The reason for that is that it's kind of a long process of getting the root locus for a system. So what we prefer is to show you the result, and then by doing it, by following the procedure and step by step, you're gonna learn root locus. So that being said, these are steps to find the root locus when you have a feedback system with negative feedback, where the gain or the unknown number k is positive or equal to 0. Okay, what are these steps? I have 7 steps. Number 1, prepare the root locus sketch. Write the characteristic equation so that the parameter of interest appears as a multiplier. So you should do something to make your feedback system's denominator look like this: 1 plus k times p of s. What this means is that you aren't supposed to have k somewhere else. You want the unknown number to be a multiplier, to be just multiplied by your transfer function. We are going to see that in our examples. Item B, factor p in terms of n poles and m zeros. So you want to write your poles and zeros separately. You want to have them simply just being multiplied. S plus p1 times s plus p2 times s plus p3, and then in the numerator s plus z1, s plus z2, s plus z3. We don't want to have 2s plus 1. We don't want to have 5s negative 3. Then we locate the open loop poles and zeros in the S-plane with selected symbols. Poles are being shown with an X, zeros are being shown with an O, and then we determine the number of separate loci. So separate loci are n when n is greater than or equal to m, and so n is the number of poles, m is the number of zeros. Finally, the root locus or root loci are symmetrical with respect to the horizontal axis. Okay, so this is the step 1, which is preparation. Step 2 is to locate the segments of the real axis that are in root loci. How do we do that? The locus is on the left-hand side of odd number of poles and zeros. Okay, that's a lot of information. Let's see a few examples. Okay, so before we start the process, remember that we plot root locus for the loop transfer function, meaning that g times h, and we don't need to find the closed loop system's transfer function. That's the power of root locus. Also remember that whatever is going to follow is for negative systems, negative feedback systems. If you have a positive feedback, it all changes. That table I showed you is going to be different. Also remember that what we are going to assume here is that k is a positive number. So this is different with Routh-Hurwitz, because in Routh-Hurwitz we were not saying that k is positive. The assumption was that k can be any number. Okay, so we talked about looking at the real axis and finding segments that on real axis belong to root locus, and we said any place on the left hand side of odd number of poles and zeros is going to be in the root locus. Okay, let's see this example. I have g given to me, and I have a negative feedback, and I don't know the value of k. I want to find segments on the real axis that are in the root locus. So what I do is to find the poles of G times this block. So this is K times G. So I'm going to have a K divided by S times S plus 1 times S plus 2, right? What are the poles of that? 0, negative 1, negative 2. Remember, this is the loop transfer function. So the poles I'm finding are not the poles of my system, they're poles of the loop transfer function. I'm going to have 0, negative 1, and negative 2. So 0, negative 1, and negative 2. The segments on the real axis that are in the locus are places that have odd number of poles and zeros on the right hand side of it. So here the segment number 1 has nothing at the right hand side of it, so it's not in the locus. This segment 2, between this pole and this pole, has one number, so one pole on the right hand side of it. So this segment is gonna be in my locus. This segment number 3, has 1, 2 poles and no zeros on the right hand side of it. So segment 3 is not in the locus. And segment 4 has 1, 2, 3 poles on the right hand side of it and no zeros. So again, it has odd number of poles and zeros on the right hand side of it, so it's inside the locus. What you see up here is the mathematical calculations for it. You should actually find the angles to see if the segment is in the locus, but the simple way of thinking about it is just to count number of poles and zeros, and if it's odd, then that segment is in the locus. Let's see another example. Determine the locus on the real axis for unit feedback in figure that we had before, if this is my system G. So again, we find poles and zeros. What are the poles? 0, 0, 0, negative 4, negative 4, negative 5, negative 5, and then the zeros are negative 2 and negative 2. So this is the drawing of it. I have 3 poles here, 2 zeros, 2 poles, 2 poles. Which one of these segments are in the locus? Well, segment 1 has nothing at the right hand side of it, so that is not in the locus. Segment 2 has 3 poles and no zeros on the right hand side of it, so 3 plus 0 is 3, which is an odd number, so segment 2 is in the locus. Segment 3 has 2 zeros and 3 poles on the right hand side of it. 2 plus 3 is 5, it's an odd number, so this segment is in the locus. How about this segment? It has 2 zeros and 5 poles, so 5 plus 2 is 7, which is an odd number, so segment 4 is in the locus. And then here again I have 2 poles, so 2, 4, and 7 poles plus 2 zeros is going to be 9. So if I'm here, I have 9 things, which means 0 and pole on my right hand side. So this segment is in the locus too. So all points in these segments are in the locus, but points in this segment are not in the locus. Okay, another example. Consider the second order system. Determine the locus on real axis. So what do?